Welcome to this explainer. Today, we are diving into how modern molecular biology is completely re-architecting the treatment for a disease that, well, literally rusts the human body from the inside out. We're looking at a fascinating biological glitch. It's just a tiny typo in the human code, but it dictates a lifetime of managing iron overload. And more importantly, we're going to talk about how we are finally on the verge of fixing it for good.
Okay, let's dive right into this mystery. Think about this. What actually happens when your body completely loses the ability to say enough to a necessary mineral like iron? We usually think of iron as this essential building block, right? It's absolutely crucial for carrying oxygen in our blood. But biology is all about that delicate homeostatic balance. When that balance is catastrophically disrupted, the very element that gives us life transforms into something incredibly dangerous.
And that brings us to hereditary hemochromatosis. This is a condition where the body has absolutely zero natural ways to excrete excess iron. Because there's no exit strategy, that unmitigated metallic accumulation basically functions as a slow-acting cellular toxin. The clinical progression here is notoriously insidious. It operates silently, leaving this metal to just build up over 3 to 5 decades before it overtly manifests. It's kind of like a ticking clock hidden in the genes, just a perfect storm of systemic hyperabsorption meeting a total lack of physiological excretion.
Section 1. The broken biological break. Let's take a look at the endocrine failure that's actually driving all of this.
So it all starts at the cellular level, deep down within our endocrine signaling pathways. In a healthy human, iron homeostasis relies on this brilliant negative feedback loop. The liver releases a peptide hormone called hepcidin, which acts as the body's master physiological brake. It circulates around and binds directly to ferroportin, which is the cellular gatekeeper on our gut and immune cells. When hepcidin binds, it forces ferroportin to be internalized and degraded. That effectively slams the cellular gate shut and halts any further iron entry into the blood plasma. Pretty elegant, right?
But here's where things go wrong. In classic type 1 hereditary hemochromatosis, which accounts for the vast majority of cases, by the way, there's an amino acid substitution known as the C282Y mutation in the HFE gene, and this completely ruins that elegant system. The mutated HFE protein just cannot form the necessary complex on the surface of liver cells. As a result, those liver cells are effectively blinded to circulating iron concentrations. Because they don't even know the iron is there, they completely fail to produce adequate hepcidin. And without that master brake, well, the ferroportin gates stay permanently open.
The devastating result of all this is that the small intestine continuously hyperabsorbs dietary iron at 2 to 3 times the normal physiological rate. Imagine leaving a faucet running continuously in a sink with a plugged drain. That's what's happening. This relentless flow absolutely floods the plasma with toxic amounts of non-transferrin-bound iron.
Section 2. Rusting from the inside. This is where we start to see true organ destruction.
Since the body literally cannot excrete the surplus, it gets driven directly into our tissues. And guys, this isn't just some abstract chemical imbalance. We are talking about the physical degradation of major organs. When this free iron builds up, it sparks what's known as the Ferritin reaction. This generates a massive abundance of highly reactive oxygen species, basically free radicals that literally shred lipid membranes, mutate DNA, and cause cell death. The liver acts as the primary storage depot, so it gets hit first, progressing to end-stage cirrhosis and severely elevating cancer risks. But it doesn't stop there. In the pancreas, the toxicity systematically wipes out insulin-producing beta cells, leading to a distinct condition classically termed bronze diabetes because of concurrent skin hyperpigmentation. We also see the heart failing with lethal arrhythmias and patients suffering from really disabling asymmetric joint damage from calcium pyrophosphate deposition. It's the whole shebang.
Section 3. The flawed fix and the limits of bloodletting. Now you might be wondering, how do we treat this? Well, for nearly a century, the medical response to this genetic cellular destruction has been surprisingly crude. No way around it. The gold standard treatment is essentially a modernized version of medieval bloodletting. By physically extracting roughly 500 milliliters of whole blood, clinicians pull about 200 to 250 milligrams of iron bound within hemoglobin right out of the body. To replace those lost red blood cells, the bone marrow is forced into overdrive, aggressively mobilizing stored iron out of those overloaded, rusting organs.
And while this is highly effective at extending lifespan and preventing early cirrhosis, this strategy has some incredibly deep biological flaws. First off, it's an intensely grueling schedule of weekly or biweekly venipunctures that places a huge physical and psychological burden on patients. But biologically, it's even more problematic. You see, inducing a state of chronic red blood cell production actually causes a protein called erythroferrin to spike, and that further suppresses the patient's already broken native hepcidin levels. Plus, completely ignoring the genetic root means this physical draining is entirely ineffective at reversing advanced complications like destructive joint damage or endocrine failure. Section 4. The New Molecular Frontier. Let's look at some targeted therapeutics.
Thankfully, we are witnessing a massive shift right now. We're moving away from venipuncture needles and advancing directly toward targeted molecular biology. Science is mapping the hormonal networks and finally stepping in to permanently repair or bypass the genetic lesion itself. First up in the translational pipeline are hepcidin mimetics. Pharmacologists have engineered synthetic, chemically optimized peptide chains like rusfertide that act as the body's missing manual brake. They bind directly to ferroportin, just like natural hepcidin would, locking down iron absorption at the intestinal gate. And the real-world results? Staggering. In Phase 3 evaluations, these mimetics have successfully eliminated the need for therapeutic phlebotomies for the vast majority of patients by strictly preventing those toxic iron spikes. For patients, this is a real game changer. It means finally being free from that exhausting cycle of the phlebotomy clinic.
Now, if we look at those external mimetics alongside RNA interference therapies like SNN124, we see an alternate, equally fascinating approach. Instead of giving the body a synthetic hormone, small interfering RNA, or siRNA, forces the body to make its own. These engineered molecules transiently silence specific genetic transcripts in the liver, actually specifically targeting the mRNA of a natural inhibitor called TMPRSS6. By knocking out this inhibitor, it basically removes the molecular brakes on hepcidin production. So the liver is liberated to massively upregulate its own endogenous hepcidin synthesis, normalizing iron homeostasis entirely from within. How cool is that?
Section 5. The ultimate genetic cure through genome engineering. Because ultimately, the goal of translational medicine isn't just to manage symptoms indefinitely, right? Even with elegant molecular tools, what we really want is to establish a definitive one-time cure. And using the incredible precision of preclinical CRISPR-Cas9 platforms, we can use optimized lipid nanoparticles to deliver molecular editing machinery straight into the liver. It physically locates the specific mutated HFE gene within the hepatocytes. Then, introducing a highly targeted double-stranded break, it uses repair templates to seamlessly correct the base pairs back to a normal wild-type sequence. Because liver cells have an extensive capacity to self-renew, fixing this defect just once could permanently restore the liver's iron-sensing mechanics. We're talking about a true permanent cure here. We are witnessing a truly profound medical evolution. The clinical paradigm is actively shifting from defensive volume depletion to proactive, code-level precision. We are transitioning from lifelong defensive symptom management, literally bleeding out a mineral over decades, to completely eradicating the cellular devastation at its very source. It's an absolute triumph of understanding human biochemistry.
So the final thought I'll leave you with today is this. For generations, patients have been tethered to a restrictive lifestyle dictated by repeated bloodletting, all to offset a single nucleotide typo in their genetic code. As programmable nucleases and RNA silencers cure conditions like hereditary hemochromatosis, it begs a massive question. How many other diseases caused by a simple genetic typo are about to be permanently rewritten? Think about it, and I'll catch you in our next explainer.